In the first problem, it says for the given information f and g, find the indicated composition. So f of x equals x squared plus 2x minus 5, g of x equals x squared plus 2x minus 2, and we're asked to find f of g of negative 3. So we always work from right to left. So what we do is we take the negative 3 and plug it into the g function for x. So now we're going to evaluate g of negative 3. So this becomes, now use parentheses, negative 3 squared plus 2 times negative 3 minus 2. If you're using a calculator, make sure you always put the negatives inside parentheses when you're raising it to a power. So here we have negative 3 squared, which is positive 9. 2 times negative 3 is negative 6 minus 2. So 9 minus 6 is 3, minus 2 is 1. So g of negative 3 equals 1. So next, working from right to left, so we plug the negative 3 into the g. Now we plug the answer to that problem into f. So now we're going to plug 1 in for f. So we're going to evaluate f of 1. So this becomes 1 squared plus 2 times 1 minus 5. Now using your order of operations, this becomes 1 plus 2 minus 5. And 1 plus 2 is 3, and 3 minus 5 is a negative 2. So the answer to this problem is negative 2. So again, work from right to left. Next problem, we have f of x given as 8x squared minus 6x, g of x equals 9x minus 3. So we're asked to find f of g of 2. So again, working from right to left, our first thing is to find g of 2. That means we substitute 2 in for the x in the g function. So now this becomes 9 times 2 minus 3. That gives us 18 minus 3. So g of 2 equals 15. Now we take that answer, working again from right to left, since we found g of 2 to be 15, we're now finding f of 15. So in your calculator, you have 8 times 15 squared minus 6 times 15. So again, the 15 is replacing the x in the f function. So this gives us 8 times 225 minus 6 times 15 is 90. So now we're going to multiply the 8 times the 225. That gives you 1800. So we have 1800 minus 90. And that gives us 1710. So our answer will be 1710. Work from right to left. This says for the given function f and g, find the indicated composition. So we're given f of x equals 4x squared plus 5x plus 6. And we have g of x equaling 5x minus 4. So we're working from right to left. So it says g of f of x. So the first thing we do is find f of x. Well, f of x is given. F of x is 4x squared plus 5x plus 6. So what does it say to do? Working from right to left, we take that answer, which is 4x squared plus 5x plus 6, and plug the entire thing into the g function for x. So now we're really finding g of 4x squared plus 5x plus 6. So that means that we substitute that in for the x. So we have 5 times the entire f function, which is 4x squared plus 5x plus 6 minus 4, because the 4x squared plus 5x plus 6 just replaces the x in the function. So we still have the coefficient of 5, and we still have our minus 4. So now use the distributive property. 5 times 4x squared is 20x squared. 5 times 5x is 25x. 5 times positive 6 is positive 30 minus 4. Our last step is to combine our like terms. So we combine a positive 30 and a minus 4, which gives us a positive 26. Next example, for the given function f and g, find the indicated composition. So we have f of x equals x minus 2 over 5, g of x equals 5x plus 2. Now again, be careful because this is asking us to find g of f of x, which means we plug the answer to f of x into the x's in the g function. Work from right to left. So we find f of x, well, that's given as x minus 2 over 5. So that means we're going to find g of x minus 2 over 5, which means we substitute x minus 2 over 5 in for x. And remember, we still have that plus 2, and we still have the coefficient of 5. So now to simplify, the 5's reduce. So that would give us x minus 2 plus 2, and negative 2 plus 2 is 0. So our answer would simply be x plus 0, which is x. Okay, the next problem says find the domain of the composition f of g. So when we're finding f of g, remember, work from right to left. So we're plugging the g function into the x of the f function. So we're really finding f of the square root of x. So remember, the square root of x is going to replace the x in the function. That gives us 3 square roots of x plus 12. So we're going to find the domain. So the only restriction to this function is the radical. And remember, the radicand, or the value underneath the radical sign, must be greater than or equal to 0. So to find the domain, all we do is we take the radicand, which in this case is x, and set it greater than or equal to 0 and solve. Well, it's already solved because we're not adding, subtracting, multiplying, or dividing anything times that x. So that's our domain. To express it in interval notation, remember, we put in our boundary. In this case, it's 0. The values that are greater than go to the right. And since it's greater than or equal to, we include our starting point. In this case, 0 with a bracket. So when we're writing our interval, the point furthest left that's included is 0. The ending point is infinity because the graph goes on forever. Remember, infinity always has a parenthesis. And our starting point in this case has a bracket because it was greater than or equal to. So the domain is all the values of x greater than or equal to 0. So we have bracket, 0, comma, infinity, parentheses. For the next problem, again, we're going to be asked to find the composition of the two functions and then find the domain of the answer. So if we look at the problem, it's f of g. So that means we're going to plug the g function into all the x's in the f function. So that means we're finding really f of x plus 1. So we'll have 5, and in place of x, we put in x plus 1 plus the 10. We can remove our parentheses, by just dropping them because nothing's in front of them. So we have x plus 1 plus 10. So our answer, when we're finding the composite, would be x 5 over x plus 11. Now we need to find our domain. In finding our domain, we know that for a fraction, our denominator cannot equal 0. So we can use everything except for the value or values of x that make our denominator 0. So what you can do to find that value is you can set your denominator to 0, and you can say that my domain is all real numbers except for negative 11, because negative 11 would make my denominator 0. So how do we say that in interval notation? So again, what I do is I put in my boundary point, which in this case is negative 11. So it can be anything on either side of it, but it just can't be negative 11. So it can be any value to the left, and it can be any value to the right, but it can't be negative 11. So how do we state that? So if we look at the left interval, the point furthest left that's included would be negative infinity. Where does this first interval stop? At negative 11. Since neither point is included, we use parentheses. Since we have two intervals, we use union. So the second interval starts at negative 11 and ends at the point furthest right, which is infinity. And again, both would have parentheses. So this indicates that our domain is all real numbers except for negative 11.